Okay, the video was interrupted. The r of a theta is 2 times v0 squared sine theta cosine theta over 9.8. So 9.8 is a constant from the physics, the gravity acceleration. And h of theta is equal to v0 squared sine theta squared over 19.6. 19.6 is 2 times 9.8. It's also related to the gravity acceleration. And in the problem, it says assume that the projectile is fired at an angle of 30 degrees to the horizontal with an initial speed of 150 meters. So V0 is 150 meters per second. Find the range R and the maximum height of the projectile. Okay, so first of all, you check that in this whole expressions, theta is only used to evaluate trigonometric functions. If this is the case, you can either use degrees or the radians. It doesn't matter which unit you use because you only concern the trig values. All right? And you don't have to worry about those two formulas. They're very complex. They're from the other computations. It's not a part of our job. We just apply those formulas. Okay? So we are given theta 30 degrees, initial velocity 150 meters per second. We're looking for the range R and the maximum height h. Maximum height h. All right, so R of 30 degrees. As what we just observed, so here we can directly use 30 degrees. We don't have to transform it to the pi over 6. So it's 2 times 150 squared sine 30 degrees cosine 30 degrees over 9.8. 150 squared is 22,500. Sine 30 degrees, 1/2. Cosine 30 degrees, square root of 3 over 2 over 9.8. Okay, so 2 1/2 cancelled. Of course, I can cancel 2 with 22500, but I feel this one looks more better than the cancelled result. So I'm going to combine this 2 with 9.8. 9.8 is a 19.6. So this, I consider this one as neat answer. I feel this one is good. Don't simplify it. Don't simplify it. Don't use calculator. It's not allowed. If you really cancel this 2 with this 22500, it is like 11250. It's also good. So this is also a good answer. Doesn't matter which one you choose, but don't put 1/2 here. That looks a little bit ugly. And don't use calculator. Don't use calculator. All right, okay, so this is a R of 30 degrees. And next, H of 30 degrees. H of 30 degrees, we're going to apply this formula. V0 squared, 150 squared sine 30 degrees squared, and then over 19.6. Over 19.6. Okay, 150 squared, we just computed, is 22,500. Sine 30 degrees is 1/2, squared is 1 over 4. Well, if you want, you can cancel 1 over 4 with this 22500. What is it? 5 is 20, 25 is 6, 10 is 2, 8 or So it's 5625 over 19.6. Don't simplify it. There's no way to simplify further. Don't use calculator to give me the approximation. That's not allowed. Don't give me the approximation because you cannot use calculator. Okay, so you can leave it like this, or you can combine this 4 with 19.6. So you can also write it like this. This is also a nice answer. I just make sure I can read it clearly. This one, both correct. This is correct, this is correct, this is correct, this is also correct. Okay? So make sure your computation is neat, your answer is correct. Don't use calculator, no calculator. No calculator. Don't do approximation. Okay, so that's it. If you have any questions about the practice exam, let me know. I'm happy to discuss. Thank you.